Okay, so first of all, let's have a look at exam blueprint. So we navigate to aws.amazon.com and we navigate to products, AWS training and certification, and get certified, and we'll click on prepare for an exam. And where we find AWS security. Okay, not in this page, I think. Let's scroll up. Okay, let's select here. Select the exam, which is AWS Security Specialist. So this is paper, it's about pure security. Okay, computing, networking, storage, database security. Okay, so when we look here, and you can see here exam overview, it's about 160 minutes exam, and exam price is $300. If you have taken previously any other AWS exam, you take 50%, means you get 50% discount voucher. You can apply for this exam. So coming to exam blueprint, you can find, and 10 sample questions you can find from here. So let's click on download the exam guide. Okay, so what we have here, so recommended AWS knowledge, okay, about following thing: AWS shared responsibility model, security controls, logging monitoring, security threats, patch management, and security automation, and ways to enhance AWS security by using third-party services like third-party firewall, like that, disaster recovery, backup and restore, encryption, access control, and data retention in case data loss. So if you look at the exam blueprint, so there are total 5 domains covered: incident response. Okay, when something goes wrong, what to do? Okay, like something crashed or somebody hacked your server or storage something. What are the steps you are going to consider? Logging and monitoring, infrastructure security, identity access management, data protection. And if you look at detailed information like incident response, given an AWS notice, evaluate the suspected compromised instance or exposed access key. Okay, what AWS does, it keep monitoring all accounts, okay, and all resources activity. Let's say you have some instance that behaving unusual way. You have an instance launched in your account that behaving unusual way, like it running some hacking tools, trying to target some instances in AWS cloud, maybe within your VPC, maybe targeting randomly on some instances. Usually you get notification from AWS, abuse notification. You have to respond to it. You have to respond to it. Are you doing it? If you're not doing, so you have to check with the instance, somebody compromised your instance or not. If compromised, what remediations you have to take. Okay, those things. Verify that incident response plan includes relevant AWS services. Evaluate the configuration of automated alerting and execute possible remediation of security related incidents and emerging issues. So it's about some like, oh yes, like your account got hacked. Okay, means like say there is some instance behaving abnormally. Maybe it's you did or somebody did. In that case, what to do? What kind of alerts you can configure? What kind of remediation steps you can take? Okay, those kind of. It's all about like strategies. It's all about strategies. Then coming to domain 2, it's about completely logging and monitoring. Okay, so we are going to focus on like how we can implement security monitoring and how we can get alerts, and troubleshooting security monitoring and alerting, designing, implementing logging solutions. Like you have IAM user account, they access your account, or you are running some web server, or maybe running a load balancer. So you want to log all the things, whatever the request hitting your service, right? You have to log them. So what AWS side solution you can use? If you log the things, then you can monitor, right? Okay, that is thing. And troubleshooting logging solution. So that's about domain 2. It's about completely logging what are the requests hitting your service or what are the requests hitting your account and monitoring. Okay, coming to domain 3, it's about infrastructure security, like design edge security, means how you can protect your edge solutions, like CloudFront, edge service, right? Load balancer you can put as edge service by implementing it as front-end load balancer, means internet-facing load balancer. Okay, so for a given workload, assess and limit the attack surface and like reduce blast radius. Choose appropriate AWS or third-party services to protect edge services using web application firewall, and you can protect edge services like CloudFront, Route 53. How you can protect from DDoS attacks. How you can protect from like application level attacks. Okay, those are the things will be covered here. Okay, it's completely about how you secure your edge services. Okay, then we talk about web application firewall that's provided by AWS. Usually, if you want to implement web application firewall, you have to purchase like firewall, like Palo Alto, Checkpoint, like that. Apart from that, what AWS side services exist? Then design and implement secure network infrastructure. So it's about how you secure your network part, VPC particularly. So there we have like a disable any unnecessary network ports protocol, like how you can protect your network using security groups, ACLs. Okay, based on given security requirement, how you segment, how you manage security groups, ACLs, and VPN, direct connect, VPC flow log, and analyzing VPC. How you can analyze VPC, those services we talk here. Then about troubleshooting network infrastructure. Then design, implement host-based security. So how you can implement security at host level? We can have host-based firewall, means the firewall within your instance provided by operating system. You can go with inbuilt firewall or you can install third-party firewall as well. Okay, then we use some services like a given security requirement, install, configure, host-based protections, including inspector, SSM, like that. Like how you can automate patching on your instances. Okay, so usually you want to patch your instance, you have to do it manually. Every time you launch instance like Linux, Windows, Mac, you have to patch it manually. Can you automate it? Yes, you can do that using SSM service. Okay, then recommended methods for host hardening, security wise, and monitoring. Then we have IAM domain 4. It's about in-depth about IAM, identity and access management. Like design, implement scalable authorization, authentication to your AWS resources. When we talk about authentication, okay, when you look at AWS, in which places, in how many ways we can assign permissions? IAM we can consider. Apart from IAM, is there any other options? Yeah, security group you can consider, ACLs you can consider from network perspective. Is there any other way? Yeah, that's identity federation. That's fine. Any other thing? That's notification service, right? At S3 level, what do you define? Bucket policies you have, ACLs you have, S3 bucket ACLs you have. Okay, so means service level permission set. You just no need to depend on IAM itself. You can also have resource level permission like S3 policies, VPC like policies also available when you configure VPC endpoint, VPC endpoint service like KMS key policy, SQS policy like that. You have IAM service level permissions and you have resource level permissions. Means service level permission. If you look at VPC part, security group is there, ACL is there. We filter traffic based on protocol address. If you go to S3 bucket, KMS service, those services, we have resource-based policy. Like Glacier, vault access policy is there. Understand? Okay, then troubleshoot authorization authentication system to access AWS resources. Then domain 5 is data protection. It's about how you protect the data when it is at rest, when it is in transit. At rest, you protect the data in two methods. One is using encryption, using access method. When it is in transit, you protect the data by enabling encryption. Like instead of sending data over plain protocol, enable transport layer security or secure socket layer. Okay, like that. So here we talk about like key management service, certificate service that used for HTTPS implementation. Okay, those topics will be here. Okay, design, implement data encryption solution for data at rest and when data is transits. So we look at all possible AWS services for this. There it is. It's total. How many domains? 5 domains. Okay, what are the possible services we cover? Like management, governance wise, audit manager, cloud trial, CloudWatch, config, organization, system manager, trusted advisor. And coming to networking part, content delivery. So these are the services we see. Amazon Detective, Firewall Manager, Network Firewall, Security Hub, VPC, Web Application Firewall. And coming to security identity compliance, these are the services we see. ECM, Cloud HSM, Direct to Service, Guard Duty, IAM, Inspector, KMS, Messi, Single Sign-On, Identity Federation. So these are the services we are going to cover. Okay, so to meet this requirement, so I have topics created. Introduction to like AWS Security Overview. Then IAM resource-based policy, where we go in depth about IAM services. And we also talk about identity federations and S3 access control, Glacier access control. And we also look at troubleshooting. Okay, authentication, authorization. Then infrastructure security, it's about completely networking part. we have in-depth VPN, in-depth VPN, along with, we have in-depth VPC along with VPN. Then we have troubleshooting network infrastructure like certificate manager service, load balancer security, Route 53, web application firewall, AWS Shield, CloudFront security, hypervisor security, system manager. Okay, that's SSM service, simple system manager, data protection using KMS, HSM, and how we can encrypt the data, which stored on EBS, S3, database, okay, like that. Then we have logging and monitoring, where we cover in depth about CloudWatch, Cloud Trial, AWS Config, configuring alerts, multi-account centralizer logging, Amazon Inspector, Trusted Advisor, troubleshooting, logging solution. Then we have compliance security control, threat detection, incident response. The first domain. The topic 8 is from first domain. And other things we see, secret manager, SCS, security hub, and artifact. These are the services. Maybe something from this page I don't have there, like Amazon Detective. Okay, because previously AWS not used to mention what services will be covered in exam. But starting from last 2-3 months, they are including what services may appear in exam. Okay, anyhow, we'll include this one also as part of our AWS security. Out of scope AWS service and features. So it says you need to have some high level knowledge, okay, from this domain, like application development services, IoT service, machine learning, media service, migration and transfer service. Means the following is non-exhaustive list of AWS service features that are not covered on the exam. These services features do not represent every AWS offering that is excluded from the exam content. Service features that are entirely unrelated to target job roles for the exam are excluded from this list because they are assumed to be irrelevant. Okay, seems they are not part of the exam, out of scope. That's fine. Okay, so as part of the AWS security specialization, so first of all, let's talk about security introduction. Then we talk about AWS security introduction. Then what are the common threats to cloud environment? Then AWS security, shared security responsibility model. Okay, now let's start with, you take your IT security environment. So we go with something called as CIA, triad model. And we also go with AAA concept. Let's say what are the basically these things. Okay. Then we point to related AWS services. So CIA stands for confidentiality. C represents confidentiality, I represents integrity, and A represents availability. Confidentiality. What is this? So it's about only making sure authorized users and processors able to access the information at rest or in transit. Okay, it's about making sure only authorized users or authorized processors can access the information. Okay, maybe information stored at rest, or maybe somebody trying to access the information via transit. Okay, so for that purpose, whatever data you are storing on cloud, you have to properly label them and store sensitive information in proper way. You have to properly label them and store sensitive information. For example, let's assume you are storing the data on S3 storage. Let's say you are storing data on S3 storage. So you need to properly label the data. Okay, maybe you can consider like a sensitive data, or you can consider general data. You have to properly label. Okay, in case sensitive data, you protect the data. First of all, use encryption. First of all, use encryption. You have to turn on encryption, and whatever the key we use, right, to encrypt the data. So we have to make sure those keys are accessible to only legitimate user who want to access the data. Okay, okay. So you configure encryption, and whatever the encryption key is there, so you have to make sure the key is accessible to only legitimate users. Understand? So you can go with like encryption key level policies. For example, you can take advantage of KMS keys. While creating KMS key, you can define who can have access to that key. So we create IAM user accounts, right? Okay, so we can grant permission to the particular IAM users. Okay, we can define what they can do with the key. They can encrypt the data, decrypt the data. Means they can encrypt the data. While writing the data will be encrypted. While reading the data can be decrypted. Or we can give just encryption permission. They can encrypt the data, means they can write the data and encrypt it, but they cannot read the data. Understand? Like that. So for sensitive data, you have to properly label. So you have to store sensitive information separately. So you turn on encryption and also define access control. You define access control. Okay, particularly if you are using S3 bucket, you can define bucket level policies. S3 bucket policies you can define, or you can go with S3 bucket access control list, not VPC is here. S3 bucket is here. This is the legacy method of S3 bucket policy. And you can go with what? IAM policy as well. You can go with IAM policies. And whatever the key you define for encryption, you control who can have access to that key. For that purpose, you can use, like if you're using KMS service to encrypt the data, you have KMS key policies where you can tell which user has access to the key. And you can also use IAM policy. Okay, this is for example, if you are storing data on S3. Understand? Let's say maybe you have some EC2 instance. You have EC2 instance, and there is some application running. Let's say application X is there. Okay, want to access encrypted data. Maybe let's say data stored on S3. Data stored on S3. So the application X that's running on EC2 want to access S3 data. Let's say that's encrypted with a key. Let's say with KMS key 101. So how you can let this application can access S3 data? Attaching role. Okay, you can create access key, secret access key using IAM, and you put that access key, secret access key within Apex code. But that's not security wise good, right? If somebody compromises your instance, they can read your application X code, they can find out access key, secret access key. What we do, we take advantage of role. IAM role. Understand? So you have to properly label and store sensitive information, no matter wherever you are storing the data. In case, let's talk about EBS volume. Let's talk about EBS volume. So you have EC2 instance running and you have EBS volume running. So you can turn on encryption on EBS volume. Okay, and how you are going to grant access? Like application running on EC2 volume can access that encrypted data on EBS volume. One way, let's say you have some user account, let's say admin, who manages this EC2 instance EBS volume. For that user, you can grant access to the key. Like say you created key 101, KMS key you created, grant permission to this user. Means whatever the instance of this user launches, whatever EBS volume he configures, he can enable encryption on that EBS volume. Understood? So some data must be encrypted based on sensitive data. Maybe you are storing like general information, maybe on S3 storage, okay, maybe on Glacier storage, or maybe storing on like a EBS volume. You can keep it open, okay, because it's general information. It's not going to include sensitive information. And logical and physical separation also you need to consider. Logical, physical separation also you need to consider. What that means here, when you are deploying applications, okay, you may have like a front-end servers and back-end servers. Like front-end servers means like usually web app servers. Usually what? Web app servers. We want to make it available to clients via internet. We can create front-end subnet. What is mean by front-end subnet? Like public subnet, right? Okay, what is public subnet? Connected to internet. Means whatever instances you place in public subnet that accessible to clients via internet. And your app deals with about database. Okay, behind scene you may have some DB server or file server, whatever. Okay, your application access that file server, DB server to perform reading the data or writing the data. So while implementing, so you can have front-end subnet which is public, back-end subnet which is private subnet. And okay, so you can make sure whatever the instances you place in private subnet not directly accessible via internet. So anyhow, application want to access this thing, so it can perform read and write operation. Via which IP address? How come NAT comes here? Application want to access the DB server, right? Which IP address will be used here? Private IP or public IP? Private IP address. Your application can use private IP address to interact with this database server. Understand? And whatever this database server, if somebody want to access it via internet, they cannot access it. Not allowed because it's not facing public subnet. So that's what we call logical or physical separation. So whatever things we define in cloud, right? Logical things, virtual machine, virtual networking, like that. If it is like on-premise, you can have like switch, like a connected to router facing to like internet. This server connected to some switch, not accessible via internet. So that we call separation, logical or physical separation. Understand? And maybe other scenario, let's assume the scenario. Let's say this is a front-end server, web app server. And as a backend, let's assume it's using S3 storage. It using S3 storage. Maybe just you are running some static web application. So it just performs reading the data from S3. Now, usually when you access S3, how do you access it? Via internet or private link? When you access S3 storage, how do you access? Via internet? How? Via internet. So you are connected to internet, S3 endpoint connected to internet, you access it directly via internet. Is there any way we can access S3 using private link privately without involvement of internet? Let's say web app running inside Mumbai region and S3 running inside Mumbai region. Is there any way I can let my web app means EC2 instance? No matter, it may be EC2 instance or ECS instance. Is there any way I can make my web app can access S3 VPC? What is VPC here? Is there any way I can create private link between my web app and S3 storage? Let's assume my web app running on EC2. It's running on EC2. Is there any way I can let my EC2 can make access to S3 using private link? What dedicated link? There must be some name, right, for that. Remember something from VPC topic. We have some concept private link, right? What is that? Usually in this scenario, when our web app want to access S3, if you directly point to S3 bucket, you will be accessing via internet only. Understand? Okay. Do you manage VPC belongs to S3? No, right? You don't manage VPC belongs to S3. S3 hosted on a VPC that automatically managed by AWS. So what I can do here, I can create VPC endpoint. Okay, VPC endpoint. So I can create a VPC endpoint that points to S3 storage. And I will make this VPC endpoint available in a subnet where my web app exists. So using this VPC endpoint, it can access S3 storage. It's via AWS private link, not internet. Okay, web app existing in like Mumbai, S3 existing in Mumbai. Okay, within same region. Okay, so your EC2 can access S3 storage using VPC endpoint. That's private link. This is not internet link. Okay, but anyhow, we have limitation with VPC endpoint. It works within region. Like I have S3 bucket, let's say 101. My EC2 instance exists in Mumbai. So EC2 instance need to be in same region. EC2 instance need to be in same region. Okay, remember what is the limitation there? VPC endpoint is region specific service as of now. In future, that may change. Okay, that also you can consider as part of separation. So what are the AWS services you can consider to achieve confidentiality? IAM, using IAM service, what you can do? Policies, using IAM, you can define users, groups, you can define policies and roles. And you also have MFA, right? Where you configure MFA? Using IAM. So you can turn on multi-factor authentication. So if any user want to make login, they have to provide OTP as well. Okay, and we have, like if you look at S3 bucket level, so we have bucket policies, ACLs. These are the S3 level services. When you look at networking part, you have security groups and ACLs. Understand? Apart from that, you can also learn third-party firewall. You can put like some checkpoint firewall, Palo Alto firewall. Can you get those AMS from AWS Marketplace? It's available. And you go with encryption mechanism. When you look at AWS, so you can consider which service? KMS service is there, HSM service there. Understand? So you can use keys generated from this service to perform encryption, decryption. We'll see all this thing practically when we go to specific topic. That is confidentiality. Confidentiality is about making sure only authorized users or processes. Process means the like application running in your EC2 instance, maybe running in Lambda, maybe running on ECS like that. Able to access information at rest or in transit. Then you have integrity. It's about maintaining consistency, accuracy, and trustworthiness of your data over its entire life cycle. Okay, it's about like we have to make sure data must be as it is there. Once you write, it must be as it is there. If you modify, it must be as it is there. We have to make sure there is no unauthorized change to that data. We have to make sure there is no unauthorized changes made to the data. No matter data either in transit or data at rest. Data cannot change in transit and ensure that data cannot be altered by unauthorized people when we consider when data is at rest as well. That represents integrity. Making sure as thing is as it is there. There may be legitimate changes to data, but no non-legitimate changes to data. Okay, for that purpose, what we can use like file permissions. Like say your data stored on instance, you have EC2 instance, let's say Ebs Volume is there. So you can have operating system level file permissions. You can have operating system level file permissions. Okay, let's say if you are using Linux operating system, so you can have Linux file system security permissions. Okay, that we call what? File security permissions. File security permissions. Like in case like Linux, we use like a chmod command, maybe grp command, chown command, many things. OS level permission set. If you look at Windows platform, you have NTFS security, new technology file system security permission. Okay, this is one method of control. So we just go to file, whatever the file folder exists on that instance, and let's say there are multiple users on that instance, we can define the permissions, like which user or which group or which service can have access to that file. And we can also use access control. Like access control means, let's assume the instance. Access control means who can make login. Example, who can log into the instance. Maybe let's say we're thinking about S3 storage, who can access that? So somebody want to access, they have to log in, right? If the data is private, okay, those things. And we also can take advantage of versioning. What is versioning? Is there anything the part of S3 we did cover about versioning? Replication means what? Replicating from one location to another location, means copying from one location to another location. Then what is versioning? Updating means storing the changes. No, say clearly. What's the versioning? What versions? That is, so you have some file 101. Let's say you have just written this file. What you have 1, 2, 3, 4, something. Okay. Now, whenever you modify the file, let's say 1, 2, 3, 4. Okay, modified. Maybe added some data. Maybe removed the data. Let's say I update file 101. Instead of directly updating existing file, it's going to create new copy file 101. What information? Let's say 1, 2, 3, 4, 5, 6, like that. You write the data. You write the file. When you update that file, like adding the data, removing the data, file will be separately stored. So this is old version. This is latest version. Okay, and you modify this file. This will become old version, and you have another file, latest version. Let's say 1, 2, 3, 1001 something file 101. So this is the latest version. Okay, so this is the latest version. This is the old version, and this is previous old version. You can also see the timestamp when those file created or updated. So you can also take advantage of versioning. Why we have to take advantage of versioning? For example, let's say you are storing your data on S3 bucket. You have data stored on S3 bucket. Maybe you have some application, okay, running on EC2 instance, making access to the data. Let's say somebody compromised this instance. Okay, let's say there may be some bad guy, hacker, compromised your instance and somehow made access to S3. Understand? Or somebody, okay, this user got like a access key, secret access key to access S3 storage. So he can access, he can modify data, right? He can read the data, he can modify. If you, okay, you have single copy, data is modified. Can you get back your original data? By default, you can't get because you don't know what is added, what is removed. Okay, to avoid those kind of issues, you turn on versioning. If this guy is trying to modify, your old file will be kept as old version. Whatever modified thing you see as latest version, you can reverse those things. That's the versioning. Okay, so S3 provides versioning feature from AWS side. Okay, then coming to EBS, do you have versioning feature for EBS? No. Your operating system may have inbuilt versioning feature. If it's there, that's okay. Or you can install some software feature that enables versioning feature. Understand? Okay, but you can take advantage of snapshots. Time to time backup you take. If you see something compromised, and you can rectify the issue. So to clear the data, you delete existing EBS volume and restore from your EBS snapshot. Okay, that you can do. And also you take advantage of encryption. Let's say somebody got access to S3 storage. Somebody compromised access to S3 storage. Let's say data on S3 encrypted using some KMS key. If the user has no access to the key, he can access S3 storage. He can see files over there, but trying to open the file, trying to download the file, downloading is nothing but reading. He can't do. And trying to upload new file, he can't do because the user has no access to S3 storage. Okay, like that. And we can also take advantage of checksum. Okay, and we can also take advantage of something hashing, digital signatures, those things. Do you know what is checksum? Okay, checksum is a hash value. Okay, how that thing works? For that we use some technology or we use some checksum tool like MD5 sum. SHA-128 sum, SHA-256 sum. These are the some checksum technologies. Okay, so what is the difference between these tools? The key size they generate means the hash value they generate. Okay, so what's going to happen here? Let's say, for example, let's say you want to transfer a file 101. You have content 1, 2, 3, 4, 5, something. Okay, what I can do, I can run a checksum tool on this file. Let's say I'm going to run SHA-256 sum. This tool I run on that file. This tool will look at the file content, not file name. Look at the file content. Based on that, it's going to generate a hash value. It's going to generate a hash value. The hash value, okay, like 256 bit in size. Hash value is 256 in bit size. Let's say we got value 1A, BC, blah, blah, blah. Okay. Now, this value is, okay, unique based on the content of the file. Even one binary bit data change in that file, this hash value will change. Understand? So now what you can do, you can transfer this file to your partner. You transfer the file and also transfer hash value also. Once your partner receives the file, he will run same tool again. SHA-256 sum tool on that file, or not one. Let's say file delivered as it is. There is no data loss. Okay, so this guy is going to get same hash value like 1A, BC. Let's say while transferring the file, maybe some bit loss due to network issue. Maybe somebody captured that file on network and modified the file, added something, removed something. So when this guy runs that SHA-256 sum tool on that file, going to get different hash value. By that, receiver person can get to know the file in the transmission is interrupted. Means maybe some bit lost because of some network issue, or somebody captured my packet, modified it, and sent. Understand? So that we call checksum. Like usually when you visit some website, okay, like they publish file and also they publish hash value. When you download that file, let's say hash value 1A BC. When you download that file and you can run checksum tool on that file, if you get same value, that means your file downloaded as it is. There is nothing modified. Usually we can see this kind of implementation in downloads. If you are downloading from some file transfer server, from FTP server or HTTP server, HTTPS server, like that. Okay, so even this checksum user, okay, in case like VPN as well. Okay, we just enable algorithms for that. VPN automatically does it. Sending side, it will run checksum value, generate hash value, it will send to the receiving device. Receiving device will run checksum value on that file. If get as it is hash value, it will consider data integrity is good. Understood, right? And so what services you can see? So you can see Amazon Certificate Manager Service, that X.509 certificate, like where you think implementing about HTTPS, secure FTP. Okay, in those kind of scenario, we can use this certificate. And again, you have to make sure data integrity is good by configuring IAM bucket policy, where you can tell who can access those services. And also you can take advantage of encryption. If somebody want to access like a data stored on S3, they need to have S3 level access and key level access. If you are encrypted the data using KMS key 101, if somebody accessing it, having access to S3 is not enough. They also need to have access to key as well, like that. See, indirectly, it's providing data integrity. And you also take advantage of versioning feature, like S3 versioning. Inbuilt feature is there. Or within OS, like if you go to Windows, Windows provides inbuilt versioning feature. Or if you install some third-party software, you can do that. And MFA delete. So it adds up additional security. Like particularly when you talk about like S3, if anybody want to delete the data, they must log in using MFA. So you can create policy. You can create policy. Like you can create policy 101, which will grant like read permission, write permission. Okay, you can create another policy 202. They can delete the data. But within policy, you have condition. Within policy, what you do? You put condition. Means what? The user must log in with MFA. Not only with MFA, like user must log in from a particular source IP, where you can tell IP address of your main branch office or sub branch office, become like that. We'll say all these things when you go to IAM. Okay, so that's why I said we are going to deep dive into IAM. Okay, and security. Got it right? Okay, next thing is availability. It's about making sure your service is available to your customers when they require it. It's about making sure Your service is accessible when it is required by legitimate clients or customers. So here we think about redundancy. Here we think about redundancy. Redundancy means what? Making sure there is alternate way if something goes wrong with existing thing. Understand? Like you can go with available cluster. Like instead of running single instance, let's say you are running some web service or app service, instead of running on single instance, we can run multiple instances. Like web app 1 is there, web app 2 is there, web app 3 is there. Like group of servers. What they say? Group of servers. Like a cluster. Cluster is nothing but group of servers in a group offering same service. Maybe you are running some HTTP service, HTTP service or application service like that. And you can go with multi-agent based deployment. Like instead of putting all the servers in single agent, put them across multiple agent, right? Okay, you can say, like, say this is agent 1, agent 2, and agent 3. But 3 instances separately accessible. How you can provide single point of contact for these 3 servers running in different availability zone? What you can use? You are running 3 instances separately in 3 availability zones, but they are identifiable with different IP address, right? Web app 1 separate address, web app 2 separate, web app 3 separate. How you can provide single point of contact to reach these 3 servers? Load balancer. So you can use ELB. So means you can consider this is nothing but target. Understand? That method you can consider. Or you can deploy your service across multiple regions. Like in region 1, you may have one instance, let's say call it as 1. In region 2, you may have instance 2, single server, but it's redundant, but deployed across multiple regions. Otherwise, you can go with the load balancer. In region 1, you are running ELB, let's call it as ELB1. In region 2, you are running ELB, let's call it as ELB2. Okay, I'm running instances in different region, but is there any way this instance will have separate address, this instance will have separate address? Is there any way I can provide single point of contact to reach these 2 servers? Right? Route 53 you can use. Okay, different policies available. Is there any other service? Similarly, here also I can use, right? I can have route 53 point to 2 different regions. I can use route 53. Apart from route 53, is there any other services? What is GA? Global accelerator. We can also use that thing. So when you are architecting, you have to design for failure. So you have to architect in such way there will be a failure. If you want to consider there is 24/7, 365 days your service is up. If you want that, you have to design for failure. Understood, right? So what are the services you can consider? Auto scaling. So that makes sure you have enough number of instances always running, but keep in mind about budget. When many instances launched, you'll be charged more. ELB to load balance across instances belongs to different availability zones within region. You can use route 53 G. If you want to load balance traffic across servers belongs to different region. So we use these services. So that what represents CIE. Confidentiality, it's about totally making sure encryption, controlling the access, and coming to integrity, we have to make sure there is no unauthorized changes. We can achieve that by using like, again, access control, encryption, and we have to use secure method to transmit the data. Availability, we have to make sure service is always available when it is requested by legitimate user. So that's what represents CIE. And we have something non-repudiation. So non-repudiation is the guarantee that an entity cannot deny something once done. It's about, we have to make sure there is a guarantee that an entity cannot deny something once it's done. Okay, for example, let's say I'm running a company. Let's call it as XYZ. So non-repudiation is the thing. We have to make sure there is guarantee that an entity cannot deny something once it's done. Okay, for example, let's say you work for a company ABC. You work for a company that's ABC. Now, let's say within company there are 2 people. Let's say manager is there, and you are the team member. Okay, let's say manager sent you a mail. Manager sent what? A mail. Say to do some configuration. Do this configuration on a router, or do this configuration on a server, or do this configuration on S3 storage. So as per his instruction, what you do the thing. You do that thing. Let's say that maybe causing some security to compromise. Okay, he told to like make that object as public, something like that. You do that one. Let's say at end of the day, something compromised. Now, so security team will be there. They are going to pinpoint to whom they are going to pinpoint this guy. Understand the team member, but he did as per instruction given by manager. Okay, he says manager gave that instruction. Okay, but actually who did? The team member. Okay, maybe let's say on premise server, he entered into that room, he did. So security team will consider this guy did. Or let's say something configured on cloud. So team member did AWS login, did the things. So they are going to pinpoint to whom? Team member only, right? But actual instruction given from manager. Let's say this guy says manager gave that instruction. Okay, and this is the mail I got. So mails can be manipulated. Mails can be manipulated. But how we can make sure the mail sent by manager only? The mail sent by manager only. Okay, so we can use something called as signature, digital signature. Like let's say, for example, you enter into airport, you show your passport. How they can recognize passport? Along with your details, they look at signature also, right? Okay, similar thing here. This one we call digital signature. Understand? So here we use digital signature for non-repudiation. So this guy can show, let's say the company, ABC company implemented all mails with signature. Every member sends the mail, along with mail, signature will also go. So this team guy can say, these are the instruction I got from my manager. This is the mail. So the security team can verify the mail actually sent by manager by using signature. It's actually digital signature. Okay, behind the scene, how it works based on PKI. What is PKI? Public infrastructure, which is combination of public key, private key. We don't use public key, private key just for encryption. We use it for integrity check also. We also use it as integrity check. Okay, to check the signature also. Okay, so when you are making AWS access, no matter you are making console-based login, and you are making CLA-based login, or you are making API-based access, all our request, whatever the request we send, right, it's signed and verified automatically. So you have AWS here, you are making access, whatever request you send, it's signed automatically. Whatever the public key, private key required, it automatically managed by AWS. So when you send a request, your request will be automatically signed using console or CLI API, and receiving side, it's going to verify the signature. If request comes from some party, unauthorized party, okay, even using proper username, password, okay, but requests are not signed, AWS is going to drop those things. Understand, right? Okay, so why requests are signed? You have to verify identity of the requester, allows you to protect data in transit, and protects against potential reply attack. Reply attack means if somebody captures that, modifies it, signature also varies. Understand, like that. To understand how this signing works behind the scene, if you go to the digital signatures here to this slide, let's assume, so this is a person, let's say this is the manager, let's say this is some person, let's say Sally. Let's say Sally works in accounting team. So Sally composes like accounting document and want to send to the manager, maybe via email or maybe via file transfer, like uploading to some site manager can download, or copying, sending via pen drive. So how we can make sure the information reached as it is the manager? It's not encryption. It's not about encryption. Digital signature does not provide data encryption. For encrypting purpose, we use separate method again. We can use separate PK. Understand? What Sally will do? Sally will compose file. Let's call this is the file, digital file, accounting file, whatever, CSV file, Word file, Excel file, whatever. Before Sally sends the file, so what she is going to do, she is going to run that file via some checksum algorithm. Let's call it as SHA-2 algorithm, like SHA-256, SHA-128, like that some algorithm. So Sally will take digital file. She will run the file across SHA-2 algorithm. What we get? We get a hash value. The hash value unique based on content of algorithm. And again, we are going to have PK as well here. What we are going to have? PK as well. PK, public key infrastructure, where we have private key and we have public key. Now, where is the key located here? Private key is with Sally. Private key is with Sally. public key with manager. So generate the key, Sally will have private key, manager will have public key. When Sally runs digital file via that algorithm, we are going to get hash value. Okay, this can be used to check integrity of that file. What Sally is going to do, it's going to encrypt this file with private key. Private key is with Sally, right? And what resultant we have? Digital file and a stamp. What is that stamp? Encrypted hash value. Understand? What result we have? We have digital file and we have hash value, and that hash value encrypted with what? Private key. We call this one as digitally signed file. Understand? Now Sally will send this file to manager. When manager receives this file, what manager will receive? Digitally signed file. What this guy is going to do? It's going to open digital file and it's going to run same algorithm on that file. Result what he get? Hash value. And also he's going to receive that encrypted hash value, right? He's going to decrypt that hash value using public key, relative public key. Okay, means this encrypted signature means encrypted hash value can be decrypted using relative public key. While generating private key, public key, okay, private key shared with the Sally, public key shared with manager. So what manager see? Manager will see decrypted hash value. He's going to compare both hash value. If both are fine, manager will consider he received data as it is. There is no change to data in transit. Understand? So this is how digital signature works. In simple word, when Sally sends the file, means first of all we have public key, private key, relative, private key with Sally, public key with manager. What Sally will do? He will run that file across a SHA-2 algorithm, get hash value encrypted with private key. Okay, now what we have? This file stamped with encrypted hash value that we call digital sign. This is digital sign. Okay, whenever somebody receives that file, okay, let's say manager receives, he can read the file because file is not encrypted here. What is encrypted? Hash value. Okay, if you want to encrypt the data, that is separate again. Understand? Whatever hash value we got here, the hash value encrypted with a private key. Now, whenever manager receives the file, he will take the file, he will run across a same algorithm, get a hash value, and is going to decrypt encrypted hash value using relative public key and look at the hash value. Both are matching. It will consider the file is valid. But for encryption, we use separate again, like HTTPS for encryption. Here you can consider this is the AWS data center, and here you are the user. You made access to AWS using console or API CLI based access. All this thing happens behind the scene. All this thing happens behind the scene. When we take HTTPS, when we take VPN connection, this thing happens automatically. This is the behind thing, how things work. Just to basically understand what is mean by digital signature. Is digital signature provides encrypting data? No. Digital signature provides integrity check. Encryption is separate part again. Understand? For encryption purpose, we can go with a symmetric encryption, or we can go with asymmetric encryption. In case symmetric, we use common key, okay, to encrypt, decrypt the data. In case symmetric, what we use? Public key, private key. Which key used for encryption? Public key for encryption. The private key used for decryption. Public key, private key, not just used for encryption, decryption. It used in many ways, like used for encryption, decryption, and to gain digital signatures. And also can be used for what purpose? Is there any other purpose we can use public key, private key? Remember from when you make login to Linux EC2 instance as part of the authentication. You can use the PKI as part of the authentication. Like you can have SSH service configured, key pair generated on your server. You can have public key on your SSH server, and you provide private key to the user who want to make access to your SSH machine, means your Linux server. That also use cases. Understood, right? Okay. Okay, that is what is by digital signatures. So when you access AWS, you don't need to worry about managing the signatures, all those things, everything managed automatically. And the AAA, this is going to add a level of security to CI model. AAA, it's going to add a level of security to CIA model. Here AAA stands authentication, authorization, accounting. Authentication means define who can access. Authentication means define who can access particularly. How you can identify a particular thing who are accessing your service? Username you can use, password you can use. Means user need to provide username and password, or access key, secret access key. If somebody user want to make access your service, or somebody program want to make access service, we can use access key, secret access key. And we can also use third-party users. So we can federate the users, like using OpenID Connect if you want to federate web identities. Okay, let's say you are running a web application on your EC2 instance. You want to let the user can use their existing account, like Facebook account, Google account, to access your service. Okay, you are running on AWS. You can go with Identity Federation. Okay, OIDC, which provides federating web identities. SML, if you want to federate Active Directory identities. And you can also use role, right? Instead of username, password, or access key, secret access key, you can also use role. So do you remember what is the advantage of role? Instead of using username, password, and access key, secret access key. Do you remember? Right? Okay. Okay, so within AWS environment, so if you want to let one AWS service can access another AWS service without username and password, access key, secret access key, we go with role. Okay, so what AWS service we can see, IAM service we can see, and resource level permission also we can see when you are thinking about authentication. Okay, but authentication means we define who, okay, that actually we do using IAM service. Authorization. Okay, authentication means we define who can access. The user need to enter something before he can access. Authorization means what allowed to access. Okay, authentication means like login, you can consider. Okay, what they can access. Authorization means level of access. Authentication means like who can access, like login, sign up. Okay, those kind of things. Authorization means once they log in, once they access, level of access. Okay, like S3 bucket, they can read only, can perform read write, but not delete. They can perform writing only, they can perform delete only, like that. Understand? If you take EC2 service, what they can do? They can just create instance, can modify instance, or they can just access Ebs Volume or just load balancer, like that. So authorizing identity access level based on permission set. When you look at AWS, how you can apply permissions, IAM policies, resource-based policies. Understand? Along with IAM policy, you can also have SCP, service control policy. Okay, about that we discuss in a topic called as AWS organization. Okay, we have a separate topic there we discuss. Okay, so you have authenticated a user, an authorized user, and what they are doing actually when they did login, and what they did actually. You want to record all activity, right? That we call accounting. Why we use accounting? For auditing purpose, security monitoring purpose. Okay, so in case AWS, what services you can consider, like CloudTrail? What is CloudTrail? What kind of information you can see from CloudTrail? What the access? Who did when? Like who did login when? Okay, and what they did? They created something, modified something, deleted something, everything recorded in CloudTrail. So it's an auditing service. Understand? And AWS Config. What is this service? No. AWS Config. It gives inventory of your resources, and it gives end-to-end history of a resource configuration. Let's say EC2 instance launcher. From that point of time, okay, let's say EC2 instance launcher 100 days back or 500 days back. From that point of time till today, what are the modification, configuration took place on that instance? It gives resource history, like who did, when they did, all those information. And also there you can also define policies also. You can define policies like if anybody launches large instance, get me alert. Okay, or somebody launches like a security group and they made SSH port open from all source IPv4 address. If you want to get alert, you can do that. And also you can take remediation action. Okay, from associate level, so you know very basic about these things. Okay, we see actual implementation in depth at our this level. Understood, right? Okay, that is introduction to security. Okay, general concepts here. Understand CIA, confidentiality, integrity, and availability. And what is digital signature? Okay, that makes sure if somebody did something, they cannot say they didn't do that thing. Okay, we use in multiple cases this one, like as part of VPN, HTTPS connection, like that. And AAA, it adds a layer of security to CIA model. So these are the security pillars. You take any IT security, no matter security on AWS cloud, maybe security on your on-premise data center as well. Understood, right? Okay. So got any question about CIA, AAA model, digital signature?